We're good? We live? Ooh, loud. All right, let's turn it down just a little bit. Cool, everyone can hear me? Everyone's good? How's Ignite doing? That's a lot better than I thought was going to happen at 9 o'clock in the morning. I could barely get out of bed. I landed in Atlanta last night around midnight. I'm like, let's do this. Get in at 2, up at 6. I'm ready. Xamarin, let's do this. I love what I do. I love every little bit of writing cross-platform native apps for iOS, Android, and of course Windows with Xamarin. I've been doing it for 5 years. Even before I joined Xamarin and before we got acquired by Microsoft. I left the prestigious career path of writing printer software at Canon to do mobile application development, and boy, was it the right decision for me, because mobile's not going anywhere. It's bigger than ever, and there's amazing opportunities, not only in the consumer space, but really in the enterprise space as well. So I've been seeing complete companies transition from having these huge like desktop machines and even like laptop machines everywhere to going to a fully optimized mobile environment to be in and out so any employee can do anything in under 20 seconds. And that's really the power of having these supercomputers that are in the palm of our hands. Now, there's tons of sessions on Ignite here about all the different aspects of DevOps and what do you do once you write the code, where do you put it in VSTS, what do you do to test it, and where do you go, all these analytics and feedback and things like that. And when they told me, we should do an end-to-end Xamarin session, I was like, well, there's already going to be like all this other stuff on DevOps, and I really want this session to be focused on building the applications and where that integrates into the other parts of the Microsoft DevOps pipeline. So I'm going to spend the majority of my time today speaking about just building, what the heck is the Xamarin thing that Microsoft acquired, why does James love it so much, and we're going to build some applications in multiple ways. We're going to tie it up to Azure. It's going to be great. Why wouldn't I throw some Azure in there? You got to throw some Azure in there. All about that Azure. Let's do it. Azure, Azure, Azure. That's what they should have come on stage with, I swear. And I am that James Montemagno, if you went to Scott Hanselman's session, who I was surprised. I got a shout out at an Ignite keynote. I was like, woo. 2 years ago, we were launching a new product, and our CEO of the company, Nat Freeman, goes, we're launching Xamarin Forms tomorrow, and maybe Scott will blog about it. And I go, all right, well, what can I do? 10 o'clock at night. He's like, can you just like whip together an app really quick? And I'm like, sure, yeah, you know what, when do we need this by? I was like 2 hours, and I was like, psh. 4 hours later, Xamarin Forms was born. And it's been this amazing demo that Scott's taken everywhere, and I've added all sorts of stuff. I'll show you that later if you didn't get to see it in the keynote. But you may be wondering a little bit who I am. Like I said, I'm James Montemagno. I'm a principal program manager on the Xamarin team here at Microsoft. And I was at Xamarin for 3 years before the acquisition, and 2 years, even before that, as a customer building applications. Like I said, I've been doing it for 5 years. And I moved from writing printer software from Phoenix, Arizona to another bright, sunshiny city, Seattle, Washington. 2-3 days a year of sun. Pretty great. Pretty great. Everyone should move there. It's fantastic. Any Seattleites? Yeah, it's amazing. All right, so I didn't move there for the actual sunlight. I moved there for the coffee. I love coffee. Half my demos are coffee. Everything on my GitHub is coffee. If you come to Seattle, or if you live in Seattle, look me up, send me an email. I'll take you out for coffee. I'm on my 14th cup this morning. It's great. I swear, I'll just pour the Starbucks down my throat. It's great. Now, the favorite part of my job is not only getting to fly all over the world, talking to all of you beautiful, amazing developers right in front of me, but it's that I still get to create mobile applications. Over the last 5 years, I've shipped 70 applications to all the different app stores. But the best part of my job now is that every single thing I do, every app I create, every library I create, is open source on my GitHub. You guys can find me anytime directly at motz, M-O-T-Z, at Microsoft.com. Nice, short, and sweet. Not this crazy long email alias. I created my own special alias. And at James Montemagno is not only my Twitter account, but it's also my GitHub page. Actually, just Google James Montemagno. There's only one of me, so you'll find me. It's a very unique name. If you want to hear more from me, I have later sessions. I have 2 more sessions here at Ignite before I fly back out to Seattle. But you can listen to me each and every week on a podcast I do that has nothing to do about Microsoft at all. It's independent. I do it in my spare time. If you like podcasts, Merge Conflict, it's a great name. We bought a really expensive domain name. So listen to that. Now, when I talk about what Xamarin is, it really kind of, how does it fit in building Xamarin, building mobile applications? Where does it fit into Microsoft's DevOps story? And it's really that develop part. going in and developing, crafting native applications, leveraging our existing C# .NET skills to build great applications on iOS and Android. And I'm going to talk a little bit later on about our full testing solution, Xamarin Test Cloud, of course, VSTS to do automated CI builds, and push to run all your tests, and test to do automated UI, and then a little bit about Hockey App to do not only crash reporting, but to distribute your applications to anyone inside your org or to your beta testers. Now, I'm not going to focus too much on the other parts besides develop, because there's amazing sessions that are all probably being recorded here at Ignite that you should go to, and I have references at the end of the actual presentation. So when I started mobile development 5 years ago, my boss came into my office my very first day on the job, and he said, James, I got 2 months to go to CES, and I need a native iOS, Android, Windows Phone, and Windows Store app. And he said, go. I was like, all right, I've written one Windows Phone app in my entire life, and you decided to hire me to be your entire mobile DevOps strategy, so good work, startup life. And I didn't know what that meant. Like, what does this native, thing mean? Like, all I knew was that I needed to maybe learn Java, learn Objective-C, do a bunch of stars and brackets, and do all this stuff. I thought that's what I had to do. But one thing that stuck out to me as I started prototyping with all these different frameworks is I was like, what does this mean to be native? Like, what does it mean to create a native application? So we were making this amazing hardware to demo, to do DVR recordings. We were a DVR company. We power all the hotels around the world, and we wanted to put the power of a DVR inside of this little phone. And it made sense that we wanted to create these rich experiences. So over the last 5 years, I've really boiled it down to 3 important things in a mobile application, but also what we deserve as developers when it comes to creating with a cross-platform framework. And first is that we want to deliver a great native user experience in the UI. There's a reason someone bought an iOS or Android device. It's because they like the look and feel of the hardware, but they also like the software. So they like the look of iOS or Android or a Windows device. So we need to get access to all that native UI or custom controls so we can add material design, and we can do everything that Apple is doing in their actual native UI experience. And as developers, we want access to the full power of these devices. So we want access to every single building block, every component, every single API. So when Apple comes out with iOS 10 and there's Siri, we want to add Siri integration immediately. We want iBeacons, we want Bluetooth, we want NFC. Anything that we can get access to, we should have. And of course, it just has to be super fast, and you have to have great performance. So as soon as a user clicks on something, it should just work. So how do we get there? And what can you do to build these applications? Well, often, even when I started, I thought I was going to have to do this, right? Boot up Xcode over on a Mac, write some Objective-C, or now Swift. And at the time, I would have had to boot up Eclipse, which is an IDE no one ever wants to boot up, ever. No one wanted to, and you still don't want to. But now we have Android Studio, which is a little bit better, but it'd be Java, so I'd lowercase a bunch of stuff just for fun. But then I'd be happy over in the C# world, where I'd be in Visual Studio, an IDE that I fell in love with a decade ago. C#, this .do it language that's just amazing with all of .NET. I'd be so happy over there. But now I'm creating the app 3 different times, 3 different languages, and I was the only developer at the time. I was like, how am I going to manage this? How am I going to test? How am I going to ensure quality for my applications? If you're working in a big organization, this is multiple teams, multiple PMs, multiple product owners, and you're just like, oh, how do I do multiple CI services? I just want one thing that integrates well. So then your boss or manager, you get this great idea, like, what if I just write everything once and just shove it in a box and just apps come out? That's what my parents think I do, just apps. What does James do for a living? Apps. Like, yes, Mom, that is exactly what I do. A keyboard, apps. You're welcome. It's pretty great. That's development. That's the easiest way. It's done. So some of these frameworks are kind of like a bunch of HTML and JavaScript and stuff that go into this magic app box, and then apps come out, and apps, awesome. But often you're kind of developing against an iOS look and feel, and Android and Windows just come along for the ride. So you don't get to really craft that great UI unless you write tons of CSS and all this stuff. And I'm a C# developer, so why do I want to write a bunch of JavaScript and HTML? And then often, not always, they're running in some sort of web browser. So you kind of get this lackluster performance experience. And that's not every single framework, and it's like in the JavaScript world, there's a dime a dozen. There's a bajillion of them. Then where do I start? Which one do I pick? What library do I do? I don't know. Just someone help me. I don't know. Just tell me what to do. And it's hard because in this experience, it's this big abstraction across like common APIs. So you're always kind of developing against their API, not the API of the platform. And this is why cross-platform mobile development actually kind of got a bad rap for a while. It's because people were going down this route, and especially early on when phones weren't as powerful as they are today and the browser technology was even more limited, you're creating these subpar experiences. And that's why Xamarin came out and decided to do something completely different to enable developers to use everything they know and love about C# to build completely native applications across iOS, Android, Mac, and Windows. Essentially, think of it like this. We've been trying to share our C# code across multiple platforms for a long time. So with Xamarin, you share all that C# business logic, your models, view models, RESTful service calls, SQL databases, Azure integration, everything that's the same that does not care about the user interface at all. Just .NET code. I just want to share it. You build a nice library, a shared library that just sits there that can be pulled into iOS, Android, and Windows. Then we give you the tools to build out a native UI across all the different platforms, while still giving you access to every single API inside of iOS and Android. So what that looks like, for instance, is if I was a Windows developer, which I've been for over a decade, I've done everything that you can possibly imagine. Like we all wrote WinForms, we all write Silverlight at one time in our lives, so we had to do it. Silverlight, good old days. We all did WPF, WCF, like whatever Microsoft told us, we did it and loved it. And we loved it because of the .NET framework, this amazing library of awesome functionality. So system XML, link, the BCL, numerics, Windows, like all this amazing functionality just like took care of all the hard work for us. Making a web request, create an HTTP client, done, awesome. Make a post async, awesome. Then if I wanted to go to a platform like Windows Phone, UWP, ASP.NET, I downloaded an SDK and I got access to some native functionality. Think of it exactly the same when you go to iOS or Android with Xamarin. You get all of that .NET goodness on the bottom. But instead of running on the .NET framework that's been restricted to Windows for so long, it's running on the Mono runtime, our original open source implementation of .NET, which is super powerful, super fast, tried and true in the enterprise for over a decade. But then we create these C# bindings around every single API in iOS and Android. So iBeacons, UIKit, MapKit. If I could add another 20 or 30,000 boxes on there, that would be the amount of iOS APIs that we bind. And they're not just these wrappers, they're C# bindings, so we add C# features like async await, lambdas, events, delegates. So even though it's a native iOS API, it's just C#. And it's with all those great features that we know and love. And of course, we do the same thing for Android. But you have the Android namespaces on top and all of the Android SDKs. And what that enables you to do is share a vast majority of your application logic across all of your different apps that you're building. For instance, some of my favorite apps such as iCircuit and TouchDraw. iCircuit is by my good friend Frank Kruger, who's actually my co-host on my podcast. It's this amazing application called iCircuit. It's a circuit simulator. It runs on every single device, Android phones, tablets, iPads, iPhones, Mac, Windows, you name it, it's there. It was actually featured inside of Apple stores when the iPad was launched, and it's built completely with Xamarin. And he's sharing anywhere in that dark color on those different platforms between 70 all the way up to 90% of code. It's a really complex, crazy application. It's pretty awesome. And what's nice about that is that he can pick and choose the actual pieces of native functionality he wants to put in. He's an iOS guy, so he has a lot of iCloud integration and a lot of the different things Apple's doing inside there with core data. So he can kind of add and spice up the applications that he wants. And if Google comes out with a new API, he can add it in there. That's why there's some difference there between the shared code, that 14, 30, 12, and 10%. That's the UI part of the native APIs. So you can share a vast amount of code. On average, our developers share 70% of code. Some of them all the way up to 99%. Like, it's crazy. Now, we do this all being 100% native without losing native performance. So what we do on iOS, for instance, we do a full ahead-of-time compilation. For some reason, my slide says AOT, ahead-of-time compilation. Ahead-of-time compile your C# down into IL, one more time into LLVM bytecode, and one more time actually into bitcode now. We run that code through the same exact LLVM compiler and optimizer that Apple themselves use for Objective-C and Swift applications, giving you a native ARM binary. But you have all that .NET runtime that's like shoved right in there, and all your C# code, and all your favorite libraries are in there. And on Android, what we can do is we can leverage how crazy and awesome Android is, because Android applications run in their own little VM with the Dalvik Art runtime, which is the Android runtime. We can run our Mono runtime side by side the Dalvik Art runtime, run all your .NET code over here in this happy, amazing runtime that's often faster than this other runtime. And we can JNI across, which is like Java P invoking, if you will, for native Android calls. But to you and to your users, there's no difference. You get this great native application that they download from the App Store, great native performance, and all of the APIs. And then you're saying, James, well, I've installed .NET before. That's pretty big. Well, we're not including all of .NET into it, or our entire runtime. What we do is we have an advanced linker and optimizer for each platform. Nothing is cross-compiled. So that means while our Mono runtime is like 40 megs, what actually gets included into your application after full linking is removed is maybe 2 to 3 megs. Doing all the garbage collection, all of your .NET code, all that amazing library, which is pretty cool. When I started 5 years ago, my boss was a little bit worried about all these cross-platform technologies and them keeping up to date. I've been along for a great ride because we've been shipping same-day support for iOS since iOS 5. Just last week, the week before, whenever iOS 10 came out, we shipped same-day support for iOS 10. Android is a little bit different. Apple has a really nice developer preview program that we can ride along with. Google sometimes does, sometimes doesn't. We shipped iOS 10 support. We also shipped Android N support. It's really important, though, for iOS to be there day one because 50, 60, 70% of all users upgrade in the first few weeks. Where Android, it takes some time. I'm an Android fanboy, and it always disheartens me to look at the Android dashboard where I think 0.2% of people are on the latest version after a month. It's sad. So you have some time, but we're there for you. We have a long developer preview of both iOS and Android. But to me, what's interesting is that where else can I put my actual .NET C# code? It's not just phones and tablets anymore. It's that I want the ability to go on anything that Apple or Google puts out, whether it's an Apple Watch, Apple TV, Android Wear, any of the Amazon Fire devices, or even Google Glass, or whatever's next. And of course, everything that Microsoft's doing. Putting in a UWP application, putting in a HoloLens application, put it on the Xbox One. We should be able to take our applications, our .NET code, and scale it to the billions of devices that are out there. That's what you get to do. And you get to do it inside of amazing IDEs. We have Xamarin for Visual Studio, so right inside of Visual Studio, 2012 all the way to 2015, and the new 15 preview. You can install Xamarin. It's actually an install option. When you install Visual Studio, boom, you have Xamarin right there to build iOS, Android, Mac, and Windows applications. If you don't have a Windows machine, or maybe you're in a team that's collaborative, and you have lots of Macs in the office, I have this beautiful rose gold MacBook that came pre-acquisition. I'm very excited. I had to sneak that one in real quick. Getting a Mac at Microsoft's really hard. Surprise. Lots of like Surface Book, just here you go. Like I kind of need this. But we have Xamarin Studio, which is an amazing IDE over on the Mac. You can do iOS, Android, Mac development there. I like to put these on the same slide because the same project, same solution, open in either IDE. So if you're in a collaborative team, you can open either project anywhere, wherever your source control is syncing, it's good to go. And when I talk about that you're creating native applications, you get access to everything, it's really true that anything that you could do in Objective-C, Swift, or Java, you can do it in C# inside of Visual Studio, to the point that we expose the same exact binding technology that we use ourselves to you as developers. So if you find an amazing iOS library that was written in Objective-C or Swift, or a Java library for Android, you can just grab that AAR or archive file or jar file, pull it into Visual Studio into a binding project, and we'll create the C# bindings for you automatically. It's pretty awesome. Best part is, all of this is free. The Xamarin Platform is included in Visual Studio, included in your MSDN subscriptions. If you don't have an MSDN subscription, you just want to toy around at home after this, and you doesn't want to build awesome apps for iOS and Android, it's included for free in the Community Edition, full-fledged, no restrictions. Publish it to the App Store, never pay us a dime. It's awesome. Something that I've wanted to say for 5 years, and it took Microsoft buying us to do it. But they did something more than that. made it completely open source. So you can see exactly what we're doing in the open. What we have open source is almost our entire product line. iOS, Android, Mac, Xamarin Forms, all of our bindings, all of our plugins are open source. You go to open.xamarin.com, you can see exactly what we're doing. You can create issues, you can create pull requests. This is the stuff that we're shipping. So you can see us do it in real time. So let's actually build a really quick application. I'm going to show you how to do this. Which one am I on? I'm on 7? 7. Perfect. I'm inside of Visual Studio. I'm inside my Solution Explorer. If you've installed Xamarin here, you just do File, New Project. Now, when you're creating a new project, you have all your other stuff like ASP.NET Core. You have like cloud stuff, extensibility. Let me go and zoom in here. And under here, when you have Xamarin installed, you get stuff like Android, Apple Watch, iPad, iPhone, down here, tvOS. So no matter what you want to build, you have access to it right here. If you want to add different extensions for iOS, such as custom keyboards, document pickers, it's all right here. Then under cross-platform is our cross-platform template. So it'll spice up and create a iOS, Android, and a Windows application for you with some shared code. So that's what I did here. So what I want to build really quick is an application that goes off and uses Bing search to do some image searching. I creatively called this application Image Search. And here's what I want to do. I'm going to show you the structure of it. So over here I have an image search portable class library. Essentially here, this is a class library that lets me go to any of these different platforms, which is pretty cool. We have a bunch of different ways of sharing code, but PCLs are pretty cool. .NET Standard, we support that. Shared projects, we support that. However you want to share code, lots of ways. But I put essentially all of my platform independent code in here. So my models, view models, my Bing image search results. So if I tap on this, this is all the JSON that's going to be coming back, and I use some JSON to C# website to convert all these, and I put these nice JSON properties to properly capitalize things over here. And then I have this image result. And this is what I want to actually expose to my application. So that's something like a thumbnail link, an image link, a file format, title, context link. So this is all just shared code, and I have all these thumbnails, all this stuff that's inside of here. And then what I have is this thing called an emotion service. So I want to do a few things. What I want to do is we have this amazing service. Let me pull it up really quick. Cognitive services. Inside of cognitive services, there's a bunch of APIs, such as emotion, face, video. All the Bing search stuff is here. If I go into the emotion engine, what I want to do is do two things. I want to go out to Bing, grab all the latest images, and then what I want to do is I want to analyze those. I want to maybe analyze and get a happiness level. So down here we can see if I take this photo, there's like a happiness level of all these people. So I could do that. So I want to do two things. That's what I want to do. Grab a bunch of images, put them in a nice collection view, and then I want to analyze these photos, which would be pretty cool. So maybe image search and analyzer would be a better name there. So I have things in here. I have this emotion service. And what's cool is that the cognitive services, they have APIs and NuGet packages for everything. So what you're going to see here is that I'm just going into NuGet and I'm adding NuGet libraries like I always have. So here's BCL, BCL build. This Project Oxford is the emotion engine, JSON.NET. And I have a bunch of other awesome helper libraries for iOS and Android, like the support libraries and all these different web image caching libraries, which is pretty cool. So let's first start off just by getting the images. So I have all this shared code. There's a lot of shared code in here. So for every page of my application, I create something called a view model. I like to do a lot of MVVM. How many of you are familiar with MVVM? OK, cool. Almost all of you. Probably everyone MVC. Yeah. There's a lot more V's, more M's. It's just a way of putting your code away from the UI. So here's my view model. So I'm going to create a UI for image searching. I have a list of images. And then down here is my query. And I just want to show you, it's literally just C# code. I have my cognitive services API. I'm going to pass it a query here, use some C#6. What do you know? I'm going to use an HTTP client. I pass my header key to it. I get a string async. I deserialize it with JSON.NET. I use link to simply convert all the Bing results to my image results. Probably done this 1,000 times. Not new. I'm not going to write this code. Just boom, there it is. So this is all in my shared code. And now what I want to do is create an Android application first. So down here what we can do is we have an Android application. We go into references. I can tap on references, say add references. I have all the NuGets in there. My projects, I have my shared code. I'm not going to add my iOS project. That would be bad. But I have that here. I have all my references. So if I need access to other .NET stuff, I have it accessed right here. And then I have all my references, lots of references. I have things like resources, so drawables, layouts. It's a native Android application. That's how you natively build an Android application. So you can go in and you have different layouts and values and string layouts. And I'm going to go ahead and tap on this main Android XML. There we go. And this is going to open up our Android designer right inside of Visual Studio. We can see my toolbox already has a bunch of different items on there. And the only thing I did is I put down this recycler view, which is a custom control from the support library. So here's what we're going to do. We're going to add in some text. I'm going to add in some plain text. Boop, into there. I'm going to add a few buttons. So these are Android native buttons, so it just shows everything that's showing up. We're going to add 2. There we go. Now this would be very hard to type text in that tiny box. So let's make it a little bit bigger. I'm going to scroll down to the properties down here, and we have, there it is, layout width. I'm going to set it to 0 dp, which is density pixels, and a weight of 1. And then boom, it fills the rest of it. So I'm like saying fill the rest of it there. Now, what this is doing is it's just actually rendering and showing the actual source here. This is Android XML. So if you had an existing Java application that you had to support, you could pull over all those resources. It's the same stuff. It's the same native stuff. And this is Android XML, which is actually why I fell in love with Android, because I was a WPF Silverlight XAML developer. And this looked exactly like XAML, except for Google wants you to know that it's Android, so they put Android, Android, Android everywhere. So, you know, and there's like lackluster data binding support, but you know, it's there. I read this. I don't even need a designer. This is how I code. And I can see this linear layout, aka stack panel. I have an edit text, aka text box, right? These are just the Android controls. And then a button. So what this does is it actually assigns IDs to each of them. So I have button, edit text, query, stuff like that. So I'm just going to change this to say search, and later on we're going to say take photo. We'll do that later, but we'll come back to the UI. So what I'm going to do here is I'm going to go into my code behind for that activity. So this activity, I've created a few things in here. So I have this recycler view, I have this image adapter. This image adapter is going to actually light up each of our cells essentially inside of it. So every single time my image collection changes, so every time I search and update it, it's going to notify and update itself. And then I'm going to inflate the layout item. And then down here, it's really simple. I just simply set the title, little name attribute, and then I'm using a library called Picasso from Square, which is one of those bindings, one of those components that'll enable me to simply grab that thumbnail link and just download cache, do all the image searching for me automatically. That's all there. So here's what I want to do is I want to come in here and I have a little bit of setup code to grab my recycler view, put it in a grid that's too wide, and then I want to go in here and I want to say, well, let me grab that query. Query, there we go. I'm going to say find view by ID, and that's going to be an edit text. I'm going to say resource.id .edit text1, great name. And then what I'm going to do is say var button. I'm going to say find view by ID button resource.id button1. And now what we can do is we just add a click handler, right? So we just come in and say button.click. And then I'm going to make this an async sender args. Just throw a little lambda in there. Nothing to override, nothing like that. That's just a click event. And what I've done here is I've pulled in all my shared code. So all my models, all my view models, all my Bing image search stuff, boom, it's all in there. So now what I can do is I can come in and just say like button.enabled, and say false first, and then button.enabled equals true. And then I can come in and say await ViewModel dot search for images async, and I'll just pass it to query. So I'll say query.text. I'm essentially mixing and matching the world of C# and Android together, because this is a native Android button. It is a button, an Android widget, and I have access to all the properties. This will happen on the UI thread, go off on the background thread and tasks, handle that all for me, and when I come back, boom, it's going to enable it right on the UI thread again. I don't have to worry about it, no callback, nothing like that. It's C# like we would expect. So now what I can do is I can go ahead and deploy this. So I'm just going to go ahead and simply tap on the emulator here. It goes out, finds all my emulators, and here it is. This is our Android emulator for Visual Studio, which is super fast, powered by Hyper-V. And then what we can do is we can build it up. And I'm just right here on my Surface. It's just going to compile everything right on my PC, all the resources, everything like that, and it's going to start a debug session right on this emulator. It could be a device. It could be anything. It doesn't matter. It's just going to start it up here. So let's see what we have as it deploys. How much time do I got? I got enough time. Okay. Cool. It's going to build. It's already built. Deploying, starting. It's in debug mode. Boom. Awesome. So I can search for something here. I can say like cute monkey, and we can say search. Disables my button. It goes off. I get a bunch of cute, adorable buttons. Monkeys. I can scroll with my finger because it's a touch screen, right? All that stuff. Pretty great. I can go and say, what else do we have? Kitties. There we go. Boom. There we go. Cool. Like that. Someone also asked me, can you search for more than just adorable animals? And I said, yes, I can. I can search for this adorable animal. And see if I get any. Boom. Awesome. So I get some images back. There's me. Cool. So now, of course, we could take this exact same logic, and then we could go ahead and make this application over on iOS. So I could come over on iOS and set that as my startup project. I'm going to tap on this main storyboard, and it's going to open our iOS designer for Visual Studio. So we have our iOS designer right here. And I can create an iOS-specific UI, access to all of UIKit. So I can use a collection view, and I can use the text box and everything like that over in iOS. Now, how this works specifically while it's loading up is that it's actually connected over to my Mac, this MacBook that's sitting right here. And you can tell by this little tiny green computer that says it's connected to our Mac agent. For iOS development, you can do it in Visual Studio. You can write code, you can compile, it'll compile to C#, but there's a lot of restrictions that Apple puts in place around where you can compile and actually build and deploy an application. So we have to live within Apple's restrictions. We can't get around them, because if we get around them, then you're getting around them, then Apple gets upset, and we don't want Apple to be upset. You know. So this is actually doing kind of a remote view into my machine. Whenever I compile it up to put on a device or simulator, it does a remote debug session, which is cool. So I've created the same exact user interface here, but all with iOS controls. So I could drag and drop any of these things around. If I wanted like a switch, I'd drag it around. I get constraints, auto layout, all that good stuff. I have a property grid. Awesome. And there's also some code associated with this here. So for instance, just like I had an activity in Android, I have a UI view controller. So I have that shared code, the image search. I have this collection view that says I am a data source, kind of like an adapter. And then down here, we can see that I'm dequeuing cells. I'm grabbing my image whenever this get cell is called, which is nice. So up here, I can say I have a few different items, but I have button search. And instead of saying click, I'm going to say touch up inside, which is the actual click event from Apple. There's a lot of different click events that they have, and that's the one that I want. It means that I've clicked down and up, and my finger stayed inside the button. So you can expect here that I'm going to do something very similar. So I'm going to say button search dot enabled equals false, but now I'm actually interacting with a UI button. And I'll say true. I also put a little spinner on there to give some indication. So I'm going to say activity indicator, and so I'll start animating. And then down here, I'll say activity indicator dot stop animating. And as you would expect, I'll say await ViewModel dot search for images, and I'll say text field query dot text. One thing I have to do here is I have to just tell my collection view to reload the data. It's not smart enough to know. But now what's cool is that I can start blending some other features together of iOS. I was mentioning that we kind of we're setting these properties, but what if I wanted to do some animations? So I'm going to zoom in because I like to show this off really cool. I'm going to say await UI view dot animate async. Notice that there's an animate and an animate async. We've asyncified and improved the iOS APIs. So this is a really cool way of doing it. I'm going to say over 1 second. Let's do a action. And we're going to set the collection view.alpha to 0. There we go. Make it a little bit there. That's cool. Async it. When that's all done, we'll go ahead and reload the data. And we'll go ahead and set the alpha back to 1. Boom. 1 line of code, awesome animations. What's really cool now is I can compile this. So when I compile it, it's going to compile my C# locally, and then when I want to put it on a device, it'll go and talk to my Mac and things like that. It just has to be a Mac with an IP address somewhere. It happens to be a beautiful, beautiful rose gold. I like to point out the rose gold because I picked it myself. It's a beautiful color. Everyone should have it. I wish that the Surface Book came in. I want everything to be rose gold. I don't know. I just love it. It makes you definitely stand out in a coffee shop. So right now, it's actually compiling. It's built here. It goes out and it finds all of my simulators or devices plugged in. So I'm going to go ahead and launch this into a debug session. And what this is doing now, it's going to do the final packaging of that iOS application. And then it's going to go and talk over to my Mac. Now, 3 months ago, it would launch a simulator over on my Mac. And I would have to swivel chair back and forth, back and forth. But we created the very first, world's first iOS simulator for Windows. So I no longer have to leave Visual Studio. I have a full iOS simulator with all the power of the simulator, and boom, there it is. Here it goes. It launches up. We can see here that I can say search. I could click it, or I could use my finger and say search. Because we've actually improved the simulator by adding touchscreen support. We can see the animations coming in and out. I can tap on it here. Again, you can search, do whatever you want. Kitty, there we go. Search again. It's going to go out, fade back in. You have the full power of Android emulators, iOS emulators, boom, right there inside of Visual Studio. You never have to leave. It's flippin' awesome. Not illegal. Yes. Yeah. It's actually what it's doing is it's going over, it's talking over to your Mac. And Scott actually, I can actually say how we do it because Scott told everyone how we did it at the keynote. He pulled up our network traffic, and essentially you can think that we're sending things very, very fast across the wire. I'm not going to tell you the code under the hood that works. But don't worry, we do everything in our power not to upset Apple. Cool. So let's do one more thing. We said that, hey, I want to go and I want to maybe add this thing here, right? This like cool image search stuff. So what I want to do is I want to come back into my ViewModel, and I want to be able to not only click on an item in the list, but I would like to maybe take a photo of something. So I could do like maybe some facial recognition of me. So I have some really cool ways of doing that. We created these things called plugins for Xamarin. Essentially, I want to get access to the camera, but I would like to do that in my shared code. I don't want to go write all the iOS, Android, all this different code to do it. Because there's a lot of common APIs across the different platforms. So when I browse the plugins for Xamarin, it's going to take me to GitHub. I'm going to go and zoom in. And as we scroll down, we're going to see a list of all these community plugins, such as Compass, connectivity, cryptography, device motion, embedded, external files, geolocator, all this stuff. Then we're going to see media. I'm going to go and tap on the GitHub page for that. And as we can see, it's made by this person. He seems trustworthy. And all the source code is all here. And you can take a look at what it supports, what we have here, all the API usage. And this is the cross-platform API for taking a photo. I say, hey, does the camera exist? Is it available? Take photo async. Go do it. Under the hood, it's using all of the iOS and Android APIs to get access to the camera. So that's what I'm going to do over here. Back in my shared code, if I scroll down, I've created these methods ahead of time. So I have one to actually, when I tap on an image, I'm going to go ahead and pass it the image URL. I'm going to use HTTP client to go get a stream, pass it to my emotion service, and then it's going to go and actually do two things. It's going to use another plugin to do text-to-speech to speak back the results, and then it's going to actually use another plugin to pop up a dialog box, all in shared code. So I don't have to write anything. Down here, I'm going to say take photo and analyze. I essentially just copied and pasted that code to take a photo async, and then down here, as long as I have one, go off and pass that stream over to the emotion service, which will handle it for me. So now what I can do is I can come back to my Android application that I have another button in there for, and I can say var button2, because that's a great name. I'll do find view by ID button. And I'll say resource dot ID dot button2 that I put down earlier. And then I'll add another click handler on there. Let's do this. We'll just copy this. Button 2. But instead of actually searching for an image async, we'll just go ahead and say ViewModel dot take photo and analyze async. button 2, perfect. And then what we can do, thank you. And then what we can do is whenever I tap a photo, I could also maybe send that image across. So I'll say adapter.item click plus equals, and I'm going to go ahead and do another async sender args there, whenever I tap on an item. And now what we can do is we can say, hey, I would like to go ahead and say await, and I want to take my ViewModel dot analyze image async, which is going to take in an image URL. And I can grab that image URL from my images list, and we'll just index into it. And my args actually pass the item that was clicked, and I'll pass it the thumbnail link. Boom, that's it. I've literally just added 4 or 5 lines of code right into my Android application to enable that. So what I'll do now, since I need a real actual camera, I'm going to actually deploy right to my Nexus 6 right here. So we can actually take a photo and do all that stuff that's on it. So what I'm going to do is I'm going to use an application called Visor, which is a free Chrome extension that allows me to pop up my Nexus 6. So you can see it on the screen. There we go. There we go. So there's my Android application. It's pretty fast. It's pretty good. And it's just plugged in USB. Visual Studio automatically picks it up and kind of good to go. So let's go ahead and we'll get deploying. There we go. There we go. So we have image search. So again, I could say cute monkey and say search. There we go. So now I can click on this monkey. Click. And it'll say unable to analyze. As you can see, Google. Because it's a monkey, it doesn't know how to analyze the face. It's that smart to know if it's a human or an animal. So let's search for somebody. Let's search for our CTO, Miguel de Icaza. I like to always use Miguel because he's got some cute photos. Cute. We can tap on him.
1.6% super sad.
Not great. He looks very like power pose.
42.77% super sad.
All right. Maybe this one.
79.54% super happy.
All right, cool. But maybe we can take a photo. So I'm going to hit the tap photo. There we go. There's me. It's a real camera. There's all these beautiful people right there. It's real live. You guys can see that. Tap back over. I'm going to do my face. Let's try it out. Hit OK. Now I was going to take that and analyze it.
Super sad.
All right, not cool. Let's try it again. Let's see if I can get 100%. I'm pretty good at this.
100% super happy.
All right, awesome. I mean, that's pretty cool. I've just gone off and into my shared code, wrote all the actual logic to go off, pull down all the data, deserialize it, take a photo, do text-to-speech, do pop-ups. I never had to write a single line of actual logic in iOS or Android to do that. Plugins can get you almost all the way there, and they're all open source, which means that a plugin doesn't do something you want. Grab the source code, put it in your app. They're all under MIT, which is really cool. I can now, of course, go do this on iOS, et cetera, et cetera. You guys get the picture. And just use all that shared code. So let's hop back over to the slides really quick. So now you may be saying to yourself, James, that's really cool, facial recognition, all that stuff. But you had to build all the UI multiple times. And maybe you now need to go to UWP. So now you got to build a UWP user interface. So you may be thinking to yourself, well, oh, geez, now what do I got to do? I got to go build the UI again, again, and again. And maybe you're just building maybe line of business applications, doing CRUD applications, or maybe you're building something like a conference application. And you want to maybe build the user interface once, but you don't want to lose that Xamarin goodness of being purely native. And that's why we created Xamarin Forms, a cross-platform user interface abstraction that enables you to create cross-platform UI in XAML, in shared code, but still create and lay down native controls for iOS, Android, and Windows. How it works is something like this, is that you have the traditional Xamarin approach to development, that shared C# logic, building UIs on top of it. And then over here, if you take a look at that shared C# logic, stare at it, stare at it, stare at it, stare at it, and then boom, it's still there, because it's the same models and view models and services and stuff, but we add Xamarin Forms on top. But you still get access to all the native iOS, Android, and Windows APIs. What's included is that we give you 40-plus pages, layouts, and controls that you can write in C# or in XAML, up to you. And with XAML, of course, you want some data binding. So boom, there's data binding. It's awesome built in. Now, we didn't see any data binding earlier with the traditional approach. It's because iOS and Android don't have data binding, but there's some great frameworks like MVVM Cross and MVVM Lite that you can use with Xamarin. But Xamarin Forms has it built right in. It also has a cross-platform navigation API, animation API, dependency service, and messaging center, kind of everything you need to get started building applications. You get things such as pages and layouts, so you can do things in master detail, flyout navigation, tab pages, absolute layouts, relative layouts, stack layouts, everything you can think about. Then you have the controls, so things like buttons, labels, list views, maps, editors, sliders, things that we could abstract that were common across the different platforms. Not every single control is there, because not every single control exists on every platform. Like a radio button, it doesn't exist on iOS. A segmented control, it doesn't exist on Android or Windows. So we did our best. The nice thing here is that you can always add and create your own custom controls and pull them in to Xamarin Forms. Additionally, since Xamarin Forms, you're creating a button, what Xamarin Forms is doing is it's laying down the native controls. It's not drawing anything. It's not doing anything. It just handles the native layouts and the native controls for you and bubbles it up to your shared code. So what's cool is that you get access to those native controls too. You can always go down and spice it up. Like I said, you can create your own custom controls, and there's tons of companies and tons of developers doing that already. There's tons of companies like SyncFusion, Telerik, DevExpress, Infragistics that have all these charts, graphs, widgets, everything already for WPF, UWP, iOS, Android, Xamarin, and of course with Xamarin Forms. You have one chart, one control, boom, you get everything that you need. Now what that looks like is something like this. If I was building an actual login page, maybe in a tabs control. Over on iOS, I would want tabs on the bottom with images and a tab controller. I want material design on Android, tabs on top to swipe through. Then I want tabs over on UWP, whether it's on phone, tablet, Xbox, it doesn't matter. I want the correct controls. So what we have here is a tab page on top with two pages, two children inside of it. And what you're seeing is a stack layout with two entries and a button. And you can notice that the entry there is for username and password with a binding to password and username. And those are essentially public properties in the code behind. So when I type something in the username box, it updates my code behind and vice versa. And then that login has some green background, white text, and it has a binding to login command, which is a method in the code behind that when clicked will call login command. So when I hit the command, it'll hit that. So let's do that really quick. Let me come back over here. Boom. Cool. Got enough time. All right, let's do this. So I'm going to open up another project here. I'm going to say My Weather. This is an application that kind of really gets the point across really well of combining all this stuff together. So when I create a Xamarin Forms application, I just went into File, New Project. There we go. And under Cross-Platform, you have Xamarin Forms templates right there, blank out. And what that does is it'll essentially go off. Here's my magnifier. And it'll create stuff like a portable class library. In this case, I'm using a shared project. And it still creates an Android, iOS, or UWP. Again, it doesn't cross-compile, so you can have all this shared logic. You can pull it into other applications that maybe aren't even mobile. You can do whatever you want. So inside of here, I have things like a weather model. So I'm going to go off My Weather. It's going to go get the weather. Go figure. I'm using a service called openweathermap.org to go off and get all this different weather. We want to maybe enter something and get the actual weather back, and maybe a 5-day forecast. So my weather service does just that. It goes off and it uses the Open Weather Map API, as you can see here, to go out and get the current conditions. So I could take this and I could jam it into Chrome, and we could go ahead and enter it. So it's just a JSON service. So I could say, what is it in Seattle, WA? It's going to return some JSON. So all I did is I went to JSON to C#.com, pasted it in there, got some classes back. Cool, like I'm a developer. And then developer. Additionally, what you could do, also you could do this, right? You could actually do edit, paste special, JSON as classes, XML as classes. Took me 10 years to find that. And then boom, it does it all for you. Pretty cool. And then I'm doing the same stuff. I can pass in latitude, longitude. I can pass in the city. I can get my weather back. I can get this forecast back. It's the same stuff that we just wrote. Then I have a view model, very similar to what we had earlier. Let me scroll to the top. I have a view model. I have iNotify property changed. I have some public properties like location, use GPS. Do I want to use imperial or metric? Temperature, condition, is busy. Then I have a forecast view, a forecast here. That I can go and it has a bunch of items for the forecast that I could iterate over to put in a list. Then I have the get weather command. And when that's called, it'll go ahead and get the weather here. So I'm doing a few things. I'm going off and say, do I want to use imperial or metric? Do I want to use GPS? And I'm using a geolocator plugin with one line of code to get geolocation on iOS, Android, and Windows. Pretty cool. Or I can enter the city and give it the location. Down here, I use a bunch of C# string interpolation to go out, get the temp, get the weather, stuff like that, and then speak back the condition. Pretty cool. So these temp and these conditions and this location is what I want to bind to in my user interface. So all that code had nothing to do with Xamarin Forms. It's just code. What I did is I went into my packages, and when you go and you create those Xamarin Forms project templates, it pulls in, down here, Xamarin Forms. Xamarin Forms, the NuGet package, it enables you to update, and we're always creating new updates to it, adding new features right there. So let's do something really quick. Let's go up over here and create a little bit of user interface. I have a forecast view and a weather view. So here's my weather view, and essentially in my weather view, I can do something like add an entry, and I'll say text equals binding to location. There we go. Spell binding correct. There we go. I'm going to put a button down here, a button, and I'll say text get weather. There we go. Space. And then I'm going to have a command. I'll do a binding here to get weather command. Cool. And then let's just slap down some labels. So I'll say text, and I'll do a binding to temp. And then I'll make that really big. Font size equals 24. There we go. And then what I can do here is I'll say a label to the text binding condition. There we go. Let's do a switch just for good measure, and we'll say is toggled, and we'll say binding use GPS. So we can use GPS if we want to. And then what I'm going to do here is I'm going to do a little activity indicator, a little spinner. And I'll say is running. I'll do a binding here to is busy. And I'll say is visible, also a binding here to is busy. Cool. So just some XAML. These are Xamarin Forms controls, but they're pretty easy. The binding's the same. You can use string formatting. You can use value converters, anything you want. I just happen to create this perfect little demo that everything is a string and everything's a Boolean. Go figure. You can also create list views, right? So I have a list view, and this is going to iterate over the item source of items inside the forecast. I have it so it recycles elements. I have pull to refresh enabled on it. I have this really cool syntax that we call on platform to say on iOS do something different than on Android or Windows. You can also say on phone or on tablet do something a little bit different. Then I have an item template, and inside of there, I'm going to put a display icon, the temp and the date. What's really cool about that is that's my user interface. I'm good to go. I have a little bit of setup code inside of my shared project to create a tab page. I set the weather ViewModel as my binding context, which will trickle down to my two children. And then down here, I set the main page. I put it in navigation, and put my tabs in there, and I'm ready to roll. Inside my Android application, the only thing I have is a little bit of code right here, just to say load application. I initialize Xamarin Forms, and I'm done. Now I can go ahead and say start over here on Android. I can go ahead and run it. This will compile up. I have all that shared code, just like I added it previously for the image search one. I have it here. So now what we can do is we can go off, build up our actual application, and get it running right here on the Android emulator. What's cool about this Android emulator is you can also fly out and control the location down over here. So as it's deploying, we'll get it ready. There we go, starting debugging. There we go. So I can come in here and I can say, what is it doing in Seattle? Wah. I'll say get weather. It's 42 degrees. And
Seattle, scattered clouds.
cool. I can say use location, and let's say Atlanta, GA. Slap that down, boom. I'll say get weather. Like, yeah, go ahead and use my location.
Atlanta, clear sky.
Pretty cool. I can go off. It's going and grabbing my geolocation based off of this latitude, longitude. I have the full 5-day forecast. Boom, good to go. Everything right there. Now if I run this application over on iOS, for instance, I can go here. I can go ahead and say run. Just make sure our simulator's still doing good there. This, again, there's no difference, just a little bit of initialization code. It's going to go out. It's going to compile our application. And then boom, here we go. It'll actually launch it up into debug mode with my beautiful splash screen that I designed myself. Pretty good. And then cool, so now I can come up in here and I can say Seattle, WA, to get weather. I can come over here and then here's my forecast view, swiping through. I could go and say, hey, let's set the location over to Apple. I don't have much control over on the simulator. If I can use that, I'll say get weather. Oh, unable to get weather, that's no good. All right, well, it doesn't want to work. Perfect. Still Seattle, still great. All right. And of course, I could run it over on UWP, right? It's a UWP application, except for all the XAML is written over in Xamarin Forms XAML, which is pretty nice. I could go and I could still spice it up with Windows 10 controls. This is going to deploy locally right here, but we'll go ahead and it could be deployed on a phone. It could be deployed anywhere else. That's a nice splash screen. Did not design that myself. Has some pull requests on my GitHub because it's all open source. I come in here again, say Seattle, WA, get weather.
Seattle, scattered clouds.
Cool. We'll say this. This should work. Say yes. Down here, we can see that little button, getting location. Oh, some bugs in my code. It's OK. We still have the forecast. We'll see what's going on. Something odd. Work. All right, it doesn't like it. You guys get the point. At least it worked on Android. All right, cool. So what else could I do with this puppy in my last few moments up here? So let's say I wanted to do something and maybe connect it to a cloud, maybe some Azure Backend. What's really cool is since it's all C#, you can have an ASP.NET Backend with your Azure code tied right in. You create a shared project that you're actually sharing logic between your mobile apps and your actual application. Now, I love Azure. I loved it even before I joined Microsoft, even before I joined Xamarin. I've been using it for a long time. I love it because of the scale of it. We have hundreds of data centers, and the compute centers are massive, as I'm sure you've heard a lot already, more than AWS and Google combined. When you're actually tying in Azure into your mobile applications, what's really great is that there's a single SDK that you can use on iOS, Android, and Windows. It's open source. It's built by C# developers for C# developers. There's also other SDKs for anything else, iOS, Android, Cordova. So no matter if you have to support other applications, you can have everything there. What's really great is it gives you full access to the full power of the REST API that's exposed to you in your ASP.NET Backend or Node.js Backend. It gives you all these data connections into SQL, Azure, tables, Mongo's, Twitter, authentication, push notifications, all that good stuff. It also handles online, offline data synchronization automatically for you. And then, of course, you just have your backend code. That's the Node.js or ASP.NET Backend. It does offline sync. That's a bunch of words on a page. It also does a bunch of other stuff, such as push notifications. Handles it all for you automatically. And it does more than just simple table data. It can do file synchronization. So let me add a backend to this application in a minute. So here's what I'm going to do is I'm going to come over to Azure. Boom, dashboard. I could hit new. I'm going to say mobile app. Search for it. There's a mobile app quick start. I could hit create. I fill in these 3 different boxes. I hit create, and I'm done. I did that ahead of time. It's here. Boom. I created a mobile app backend for my application. This one's running with a Node.js backend, but it could be an ASP.NET backend. It's tied over here. It's a full website. It's actually a website right here. Have some swagger on it so I could see all my tables, everything that's coming in. What I did here is it's a full application, so I can get every single access to it in app service. I have some easy tables, which are actually tables from an Azure SQL. So I can see here's my weather location. I have a blank table. There's nothing in it. So what would be cool is what if I could just save and load my actual cities automatically into this application? So what I've done here is I've gone in and I managed NuGet packages, and I added the Azure mobile client and the SQL backend to it. So what's cool here is that I can come into my shared code, into my Azure service, and I wrote this code ahead of time. It is 140 lines of code that gives me my weather location with some JSON properties for ID and Azure version to do online, offline sync. Gives me my tables. Here's my app URL. I go and create my mobile service client. I define my store where I want to save it, and I define my table. The Azure Service Client will automatically handle online, offline data synchronization for me. To do data sync, I just say push async, pull async. That's it. Push my data, pull my data. Done. If I'm offline, don't do any of that because I'm offline, and it'll just give you back the table. I've created two little methods here to get the locations and to add a location. So here in my get locations, I just say on my table, order by name, enumerate that. Over here, I say add location. I create, just make sure it doesn't exist already. And then here I say weather location name, insert it into my table, sync the locations. Done. Back in my view model, I've created a few other little helpers here. I have an add location command, which goes off and simply goes off, uses adds my location inside of here. Then I have a pick location command, which will pop up a sheet to let me pick my locations. So check this out. This is really cool. I'm going to come back into my weather view, and then I'm just going to go ahead and slap down a bunch of buttons. It won't be the prettiest user interface, but you guys get it. Pick, add, and we'll say pick location command. We'll say add location command. There we go. Now let me just go ahead and start this up over on Android. I'll say start. Start it up again. 2 lines of code, just a little bit of Azure Backend there. Now what's going to happen? That's going to come up, and I can say Seattle, WA. Of course, I could get the weather again. Weather.
Seattle, scattered clouds.
I'm going to say add. Saved it. What's really cool here is I can come back into my Azure portal and hit refresh. There it is. Seattle, WA. Awesome. I can come over here. Maybe we'll do Atlanta, GA. We'll say add. Saved. I can say pick. It's got the 2 options there. I'll just hit that. It sets the location here. Could do pick again. Atlanta. Cool. It's all coming from Azure online-offline synchronization, which is cool. Now, what's really great about this is, of course, it's back here in Azure, but as long as this code that I didn't test last night still works, we can run it on us. We'll just go with it. Why not? Let's see what happens. I should be able to run on iOS, Android. I could have a website for it. It shouldn't matter. I'll just say pick. Boom. Automatically in my Windows application, Atlanta, get weather. Awesome. A few lines of code. Pretty flipping cool. All right. There's a whole bunch of other stuff we do for end-to-end, such as putting it into VSTS to give you a full one place to do automation. Every time you commit code, builds your application, sends it to Hockey App, sends it to Test Cloud, sends it to whatever you want it to do, signs your application, ships it, done. One place for iOS, Android, Windows, Mac, everything possible. You can build it in the cloud. You can build it on your own machine on-prem, whatever you want to do, very flexible. For testing, we built the world's largest device test lab. It's called Xamarin Test Cloud. I have a session on it later today. I hope you join me. It's only 45 minutes. It's pretty cool. You can do all of your user interface automation locally for free and then ship it to our Test Cloud. Test Cloud's paid product, where we have 2,400 unique iOS and Android devices. This works with any application written in any language. And of course, we can distribute and monitor with Hockey App to get crash analytics. And I want to talk about a company in the last few minutes that I have here, which is a company local here in Atlanta, the actual Coca-Cola bottling company, the world's largest distributor of Coke, because Coca-Cola is, as you would expect. I'm going to show a video real quick of their story using Xamarin in this end-to-end solution.
Coca-Cola Bottling Company Consolidated is the largest independent bottler across the United States.
Most of our account reps stay out on the road most days, so we need mobile solutions. We need mobile solutions that work fast, that can work offline.
We created a tool in which it was very fast, very efficient, and you could have the creative conversation you need to close the deal at the end of the day.
Xamarin is the complete lifecycle solution for creating mobile apps. It allows our team to create apps using the existing C# knowledge, but still create native apps with a very little learning curve. We deploy a variety of devices. Being able to develop for all-in-one is a huge benefit.
Using Xamarin Visual Studio allowed us to have all of our code in one place. Cloud integration with Azure and debugging and load testing and insights all just make it something that it's easy to use.
Xamarin has allowed our really awesome mobile application and backend developers to straddle both worlds. They can go from writing a ASP.NET backend and writing MVC controllers and dealing with the entity framework to doing mobile application logic and how they're going to sync down data from that backend to the mobile application. They can go from literally the front end to the back end, and it's all the same language, same skill set, same frameworks.
Having the ability to have immediate access to the information is critical. When you go into rural areas, often we do not have internet access. So we needed a tool that worked regardless of where they were, whether they're inside a hospital or in rural West Virginia.
SQL Azure and Azure Mobile Services helped us create that connection back to the network when network was not available. We use Xamarin for mobile development, connecting to the Azure Cloud Services for all kinds of syncing and data handling. We also use .NET and Angular for our web-based solution, which also then integrates with Azure Cloud Services.
Xamarin and Microsoft Visual Studio allows any of our developers to solve any of the business problems on any device, on any platform, today and in the future.
It's an amazing story of what Coca-Cola was able to do, and I thought, what would be better than me just showing you a video, but get the man from Coca-Cola himself, Jason McGraw, up here on stage to tell you how they use Xamarin and a full end-to-end solution to build applications for Coca-Cola Bottling Company. And I'm super excited. Give him a big round of applause for Jason McGraw.
Hey, good morning, everybody. I'm Jason McGraw. I'm a .NET developer, a Xamarin enthusiast. I started my career working on ASP.NET web applications, and from there I became pretty well versed in C#. I really fell in love with the whole Microsoft stack, entity framework, web API, MVC, all of that. And I eventually made the decision that I wanted to get into mobile development. And when you make the decision that you want to get into mobile development, there's a couple different routes you can take. You could start doing Objective-C and Swift to do iOS, or you could do Java and start doing Android, or HTML and CSS and do hybrid, whatever. Or if you're like me and you like C#, you could use Xamarin and write C# and develop for all three of the major platforms natively. So that was kind of a no-brainer. So I started using Xamarin from there. Been a big fan ever since. I built my career around it. I'm happy I did. I really do think it's changing the landscape of mobile development. So I work for the Coca-Cola Bottling Company, Consolidated. We are the largest independent Coca-Cola bottler in the US. We mainly serve southeastern territories, and currently we're undergoing growth. We're expanding our territories. We do something $1 billion in revenue each year, and a lot of that is brought in by our on-premise sales representatives. Our on-premise sales representatives, they're out in the field, they're visiting customers. And you know, their typical traditional sales process was to print out some sales materials that were relevant to the customers they're going to visit that day. And they would go visit those customers, flip through the pages, hopefully be able to use these materials to aid in their sale. And that sounds probably kind of archaic, and our business thought the same thing. And that was when we decided that our on-premise sales reps could really use a mobile app. And that was how the Marketplace app came to be. So this app was going to have to run on an iPad. We needed it to be really quick, really slick. This thing was going to be in front of customers. We couldn't have it lagging on us. I needed to work in offline situations. These guys are out in the field, so we couldn't always rely on a web API request to serve up content and data for us. We needed a content management system that was hosted in the cloud. We didn't want to have to deal with any of the enterprise, on-prem, red tape, firewalls, VPNs. And we wanted a kind of cloud source control as well. Same thing, we didn't want to have to set up a TFS server. And then also, this is going to be our first Agile project. So we needed some kind of project management software that had a Scrum board. Now, when you have these requirements, there's a couple different routes that you can go. And one thing that we definitely considered was going to a vendor, because usually kind of one-off projects like this, sometimes in an enterprise environment, you're not sure if you can handle it. And we obviously made the choice to use Xamarin. We have ASP.NET web applications that we use on a day-to-day basis. So we have C# developers internally. And with Xamarin, we thought we can probably handle this ourselves. And we were familiar with Microsoft, and we figured we should go with that. So we wanted to see what kind of products Microsoft had to offer to help us get this project done. So we ended up choosing to use Xamarin Forms to build the app. We wanted to leave the door open to go cross-platform. And as you saw, Xamarin Forms gives you that to the best of its ability. We used ASP.NET Web API for the back end of our content management system, which we hosted in Azure. And then another great thing we had in Azure was Azure Mobile Services. And Azure Mobile Services let us do the offline data sync, which was great because writing a sync framework was probably really hard. This was really easy to use. We had all of our code repositories hosted in Visual Studio Team Services, and we also had our Scrum board there. And it's really great having your project management software and your code repositories all in the same place. As time went on, our needs also grew. And luckily, the things that we chose to use for Microsoft were able to grow with us. We really needed some kind of error tracking, performance monitoring software so we could really know how the app was performing out in the field. And we ended up taking Xamarin Insights right out of the box and implementing that. Turned into Hockey app later, same thing, just as good. We needed a way to do better at builds. We were doing manual builds and deployments in the beginning, and at one point, we had our QA engineers and our developers in separate buildings on each side of the campus, and our QA engineers would actually have to walk across campus, plug up their iPad, and get the app deployed to their iPad, walk back, try and test it, and then maybe a developer left something commented, oh no, it didn't work. Now they got to walk all the way back across campus, and I mean, what a huge interruption to our process. So we ended up being able to use Visual Studio Team Services for automated builds and deployments, and that really helped things flow a lot smoother. And aside from our technical requirements growing, we also changed our project management structure. We decided that Scrum was no longer really best suited for us, and we wanted to move to Kanban. And Agile Kanban has been great, and of course, Visual Studio Team Services had a Kanban board that we could use. So that worked out really nice. And we ended up getting our app built, getting it shipped, and we've received a lot of great feedback on it. Whenever a business sponsors a project for their IT department to do, you know, the whole entire purpose of it is so that it adds value to the company. And as soon as we shipped it out, I mean, we started getting great feedback. All of our on-premise sales reps said that this really improved their day-to-day lives and helped with their sales process and ultimately helped the company generate more money. So just to kind of wrap up, a couple things we really love through this process. The adoption. You know, all of these softwares, Azure, Visual Studio Team Services, Xamarin, very easy to use. And our guys that were working on the Xamarin project, they could also work on the ASP.NET backend, vice versa. So having that ease of adoption really made the process a lot less painful. The ability of everything that we chose to use. I mean, you can do so much stuff in Azure and Visual Studio Team Services, and there's been nothing that we've thrown at it that it couldn't catch. And then having the support from a company like Microsoft. I mean, anytime there was something we weren't really sure how to handle, how to approach, we had 4 engineers on the phone with us a week later. And then most of all, we were very happy that we were able to successfully do this project internally and not go to any third-party vendors. So I want to thank Microsoft for providing a great suite of tools for us to use. I want to thank all of y'all for being with me. I'll pass it back to James.
Cool, thank you so much, Jason. It's so awesome to see kind of everything come together, the stuff that I fell in love with, and seeing amazing companies around the world be successful with this entire DevOps workflow. Whether you pick one or all of the sections of Visual Studio Team Services and Microsoft and Xamarin together, you're going to love it. And if you don't, email me. You have my direct line, motts@microsoft.com. I'll make you love it, just like I do. You can get started today at xamarin.com. We have a nice little portal for DevOps. These slides are already available. There's a bunch of other great sessions that some have already happened, some are still happening. I have a cross-platform panel this afternoon, and I also have another one later on about Xamarin Test Cloud. And with that, I hope you guys all have an amazing, amazing time at Ignite, and thank you guys so much.